Hi students, welcome to the class. Today's topic is interrupts in 8051. Before going to the topic, what is interrupt? Okay, so first we can discuss what is interrupt. In our day-to-day life, if we are browsing something, when a call comes, this call is an interrupt. Okay, so if we are browsing any video, something like that, when a call came, the call is definitely an interrupt. Since our phone manufacturer given the priorities, okay, for the interrupt. Okay, so in the case of phone, the call have higher priority. So when we are browsing, if the call came, we should respond to the call. Otherwise, attend the call or block the call, anything, you should respond. It's forced to respond to the call because the call has higher priority. Okay, so that call is an interrupt, and since it have higher priority, we should attend, or it is forcefully we should respond to the call. Okay, so likewise, if you are in a call, if a message arrives, this message is a interrupt. Since the manufacturer given the call has higher priority, the call will not cut. The message will receive in the background. Okay, after the call, after finishing the call, we can take the message. Likewise, if you are texting someone, if a call arrives, definitely the call is an interrupt. So in order to uh, so we should stop that typing and should respond to the call because the call have higher priority. So this is the interrupt. If you are doing something, if you are doing some action, another process will came with us. So we have to respond to them according to the priority. If it is a call, we should respond at that time. If it's a message, it will be looked afterwards. Okay, if you are browsing a video, we can see the message after seeing the video. Okay, so there is an interrupt. So when an interrupt came, when a high priority interrupt came, we should stop the low priority action and should continue the high priority interrupt. If we are doing a low priority, if we are doing a high priority action, when a low priority interrupt came, we can do the low priority interrupt after finishing our high priority process. Okay, so this is called interrupt and priority. Likewise, in 8051 also, there is interrupt and the priority of different interrupts. Okay, an interrupt is an external. Okay, an interrupt is an external or internal event that interrupt the microcontroller to inform that the device need its services. Okay, so if microcontroller is doing something, if an interrupt came, the interrupt want the service of microcontroller. So microcontroller will look at the current process and compare it with the interrupt. If current process have higher priority, the microcontroller will continue the current process. If the interrupt has higher priority, then microcontroller will stop the process and take the interrupt and continue to do the interrupt. And after completing the interrupt action, we are doing, the microcontroller is doing the pending action. Okay, so this is how. And when an interrupt came, the interrupt want the service of microcontroller, that is 8051. For every interrupt, there must be an interrupt service routing or handling the interrupt. Okay, so interrupt service routing, ISR, is nothing but it's a service for handling the interrupt. So if there is an interrupt, then the interrupt will handle by interrupt service routing. It will uh, it will monitor, or it will scan the interrupt and we'll find is it is a higher priority interrupt or lower priority interrupt. If it has higher priority, the ISR requests the 8051 to continue the interrupt, or if it is lower priority, the ISR keep it in a table. That table, it is called interrupt vector table. Okay, so when an interrupt is invoked, a microcontroller run the interrupt service routine. For any interrupt, there is a fixed location in memory that hold the address of its interrupt service routine. So there is a location for holding the address of interrupt service routine. The group of memory location to hold the address of interrupt service routing is called interrupt vector table. So interrupt vector table is a location which is used to hold the address of interrupt service routing. Interrupt service routing is used to handle the interrupt. Okay. So in 8051, in effect, it has 6 interrupts including the reset. Excluding reset, it has 5 interrupts. So we have already discussed when we are discussed about the architecture. We have two external, 8051 has 2 external interrupt and 3 internal interrupt. Okay. So excluding reset. So when we include the reset also in 8051, there are 6 interrupt. Okay. So this is the 6 interrupts of 8051. Here the interrupts are written in a priority wise. So higher to lower priority. Okay. So this is the priority. In this first box given the different types of interrupt. Second box given the priority which is written in higher to lower priority. And the third is interrupt service routing ISR address. It's also important. Then fourth is its details. Okay. Details of the interrupt. Okay. So first we are okay, the 6 interrupt are reset, external interrupt 0, external interrupt 1. These two are external interrupt. Then internal interrupts are timer 0 interrupt, timer 1 interrupt, and serial communication interrupt. So these are the 6 interrupts. So we are writing here in the decreasing order of their priority. So first higher priority, that is reset. Reset has higher priority. If any interrupt came, if you are pressing the reset, it will not consider any interrupt. So in reset have higher priority. So we can write it as 0. So higher priority. The address of reset is 0000 and it is non-maskable interrupt and also it's vectored interrupt. Non-maskable interrupt means it cannot be maskable. If it is a low priority interrupt, it can be maskable, but reset cannot mask or cannot, it should be considered because it is the highest priority interrupt. Then the second priority is external interrupt 0, that is INT 0. And it has an ISR address is 003. And the third priority interrupt is timer 0 interrupt. So first came the 0 terms, that is external interrupt 0, timer 0 interrupt. Then the fourth, the timer 0 interrupt has an ISR address is 00B. Then next priority interrupt is external interrupt 1. It has an address of 0013. Then timer 1 interrupt. It has an address of 001B. Then last we have the lowest priority interrupt is serial communication interrupt, that is TI or RI, that is transmission interrupt or receiver interrupt. This is the lowest priority interrupt. It has an ISR address of 0023. These 5 interrupts are maskable and vectored interrupts. Okay. So priority basis first is reset. The second one is external interrupt 0. Then timer 0 interrupt. Then external interrupt 1. Then timer 1 interrupt. And the last one is serial communication interrupt. Okay. The timer and serial interrupts are internally generated by the microcontroller because they are internal interrupt, and the external interrupts are generated by the device that are externally connected to the microcontroller. The internal interrupts are generated inside the microcontroller, and external interrupts are generated externally through the connected to the microcontroller. Okay, these external interrupts can be edge triggered or level triggered. This is an important term. This external interrupt may be edge triggered or level triggered. Okay, when an interrupt occurs, the microcontroller execute the interrupt service routing of the corresponding interrupt. So when an interrupt, the ISR is not working all the time. When an interrupt came, the microcontroller execute the interrupt service routing in order to handle the interrupt. Okay. Now next is enabling and disabling an interrupt. Upon reset, all the interrupts are disabled or masked. Okay, reset is the higher priority interrupt. So upon resetting, all the interrupts are masked or disabled, meaning that none will be responded to by the microcontroller if they are activated. So if we are press the reset button, if any interrupt came, none will be considered, that all interrupts are masked. The interrupt must be enabled by software in order for the microcontroller to respond. So the enabling and disabling is done by the software. Okay, so interrupts are controlled mainly by three special function registers, that is IE, IP, and also TCON special function register. So the interrupt is controlled by three registers, that is IE register, IP register, and TCON register. These are special function register. So we can discuss in detail about these registers. Okay, the first register is IE register. The full form is interrupt enable register. As the name itself, it is clear that it is used to, this register is used to enable or disable the interrupt. Okay, disabling it is a bit addressable special function register. So if the bit is 1, then enable the respective interrupt. If the bit is 0, IE register bit is 0, then disable the respective interrupts. So the IE register is nothing but it is in IE register the five interrupts are placed in IE register. If the if IE register is 1, then the corresponding interrupt is enabled. If it is 0, the corresponding interrupt is disabled. So this is the IE register. It's very important, IE, IP, and TCON register. Okay, this is the IE register. This is LSB and this is MSB. That is IE0 to IE7. Okay, so this is LSB is IE0, IE1, IE2, etc. So these interrupt are written in the increasing order of their priority. So first we are not considering reset here. Okay, so the first interrupt is external interrupt, that is EX0. Then next interrupt is external. E is enable. Okay, E4, here E4 enable. Enable external interrupt 0. This is enable timer 0. This is enable external interrupt 1. This is enable timer 1. And this is nothing but enable serial port control unit, ES. Then we have ET2. This is reserved, and we have EA. Okay, so we can discuss each bit. This is bit addressable, each bit one by one. So the first one is EA, MSB. EA means enable all control bit. Okay, so this is the I interrupt enable IE 7th bit. So it is cleared by software to disable all the interrupt independent of the state. So independent of the state, IE0 to IE4. So IE0 to IE4, we have 5 interrupt. So independent of this interrupt, this EA pin is used to clear or disable all interrupt. If you want to disable all interrupt, the software will clear this EA. So EA will be 0. Okay. So the next bit is IE0, IE6. So IE6 is reserved bit. It is not used in 8051. The next bit is IE5, that is external, enable interrupt. Okay, IE5 is reserved for 8052. Okay, this is reserved for 8052. This is also reserved, and this is reserved for 8052. So these two are IE6 and IE5 is not used in 8051. So its value will be 0 always. Okay, so next bit is ES. ES is IE 4th bit. That is enable. E means enable serial port control unit. Okay, so it is controlled by TI or RI flag. Okay, transmission interrupt or receive interrupt flag. Okay, if it is 1, this interrupt is enabled. If it is 0, this interrupt is disabled. The next bit is IE3. This is enable timer 1 control unit. Okay, enable timer 1 control unit. Then next is IE2 bit. It is controlled by timer 1 or counter 1. Then next is enable external interrupt 1 control bit, that is set and reset by INT1. Then next IE1 bit is enable timer 0 control unit. This is the bit IE1 is enable timer 0 control unit. It is set and reset by timer 0 or counter 0. Then the the first LSB bit is IE0. It is enable external interrupt 0 control bit. Okay, enable external interrupt 0 control bit. Okay, so these 5 bits are set and cleared by, set and unset by, okay, set and cleared by the software to enable and disable the interrupt. Okay, so in order to enable the interrupt, we should set these all the interrupt. In order to disable the interrupt, this should get cleared. Okay, these bits are cleared. So that's all about interrupt enable. Okay, then next register is interrupt priority register, that is IP. It is used to set the interrupt priorities for programmer. This is used to, the first interrupt enable register is used to enable or disable the interrupt. This register is used to give the priority to the register. Okay, so this allows the low priority interrupt to interrupt the high priority interrupt. If the content of IP register are 00, then these interrupt priorities are not programmed. The microcontroller executes in a predefined manner, and in order is INT0, TF0, INT1, TF1 and SI. So these are the interrupt priority bits. Okay, it is a bit addressable special function register. So this is the priority interrupt priority register. If it is 1, it has high priority. If it is 0, it has low priority. So we have priority. This is external interrupt 0, priority priority control bit of timer 0, priority control bit of external interrupt 1, priority control bit of timer 1. This is PS is priority control bit of serial port control bit. Then the other 3 bits are reserved. It's not used in 8051. Okay, so IP7, IP6 and IP5. IP5 is reserved for 8052. So IP7, IP6 and IP5 are reserved, since in 8051 its value will be 0. Then we have IP4, we have PS, that is serial port priority control bit. It is set and reset by TI or TRI flag. Okay, if it is set, it has higher priority. If it clear, it has lower priority. It is done by software. Then IP3 is timer 1 priority control bit. Okay, it is controlled by timer or counter 1. Then PX1 is external interrupt 1 priority control unit. It is controlled by INT1. PT0 is timer 0 priority control unit. It is controlled by timer or counter 0. Then the LSB bit is PX0, which is the IP0. It is an external interrupt 0 control bit. Okay, priority control bit, which is controlled by INT0. Okay, these are set and cleared by a software, and if it is set, it has higher priority. If it is clear, it has lower priority. So that's all about priority register. Then the third register, the last register, is TCON register of 8051. This is TCON register. This TCON register have 8 bits, and it contain not all the 5 interrupt. It contains only timer and external interrupt. Okay, so we have, there is a TF1 and TF0. This is timer overflow 0 and timer overflow 1. And we have TR1 and TR0. This is timer run 0 and timer run 1. Okay, then we have IE1 and IE0. This is external interrupt 0 and external interrupt 1. And we have IT1 and IT0. This is external type, okay, interrupt type 0 and interrupt type 1. This is external interrupt edge and level trigger. This is type 0 and type 1. This is type 0 and type 1 is, if it is 1, this is edge triggered. This is 0, it is level triggered. It is based on the external interrupt. We already said external interrupt is edge triggered or level triggered, which can be that information can be get from here, that is IT0 and IT1, which deals with the edge and level triggering of the external interrupt. Okay, so we have TCON register control of the following timer operations. We have start and stop timer 0 and timer 1. Okay, we have timer run control unit. timer run. TR means timer run control unit, which is for timer 0 and 1 for start and stop the timer 0 and 1. Okay, in order to start and stop the timer. Then provide status of timer or counter overflows. Then there is a timer overflow flag. This is used to find the status of overflow. Okay, then provide status of external interrupt. Then we provide the status of external interrupt by IE0 and IE1. Then configure external interrupts as either low level triggered or falling edge triggered. Okay, this the stat is this IT0 and IT1 gives the external interrupts whether it is a low level triggered or it is edge triggered. Okay. So these are the 8 bits of TCON register. This is TCON 0 to TCON 7. Then first TCON 7, that is timer 1 overflow flag, and TCON 5 is, so we can look first to overflow section, that is timer 1 overflow flag and timer 0 overflow flag. These are set by hardware on timer or counter overflow. If a timer or counter overflow is happen, it will set by hardware, and it is cleared when ISR get executed. After the execution of the interrupt, ISR get executed, this bit will be cleared. It is set when timer or counter is overflow. When timer is counter overflow, these 2 bits are set. Okay, if timer 1 is overflow, this bit is set. If timer 0 is overflow, this bit is set. Then we are looking about then we are looking about timer 1, TCON 6 and TCON 4. Okay, here that is timer 1 run control unit and timer 0 run control unit. This is set and cleared by software to run timer or control. Okay, that is on and off. In order to on the timer 1, we are using TCON 6. In order to off that on and off the timer 0 run, we can use this TCON 4th bit. Okay. So that's about timer 0 run and timer 1 run. Okay. Then next we have external interrupt to 1 edge flag and interrupt to 0 edge flag. Okay. That is IE. IE means interrupt. IE means interrupt edge. So interrupt to 1 edge flag and interrupt to 0 edge flag. It is set by hardware when external interrupt edge detected. And it is cleared when the ISR get executed. Okay, if it is cleared when ISR is executed, if it is set by the software when it is an external interrupted edge triggered. When external interrupted edge triggered, then for interrupt to 1, it is set. When external interrupt is edge triggered for interrupt 0, then it will be set. It will be reset when ISR is completed. Okay. Then we have the last one is TCON 2 and TCON 0, that is interrupt 0 of type control bit and interrupt 1 of type control bit. Okay, it is set and cleared by software. Here negative edge or low level trigger is external. The external interrupt is low level, then here we are using interrupt 1 type control bit, interrupt 0 and type control bit. If the external interrupt 1 is negative edge or low level, then interrupt 1 type control bit is set. If external interrupt 0 is edge or negative triggered or low level triggered, then interrupt 0 type control bit is set. This will reset cleared by software. Okay, set and reset by software. Okay, if the ISR is executed, then it will be cleared. So that's all about interrupt and different interrupt registers. Okay, so that's all about today's class. Thank you.